Hello Internet, in this video we are going to be taking our STL exporter that we made a few months back and bringing it into some of the newer projects we've been working on. I've brought in our mesh preview renderer that we have, as well as Archimatix, and we are going to combine all three of those and be able to export models we create in Unity into an STL file, with preview obviously, that we can then hopefully 3D print. So that's sort of the idea. So I've kind of modified this preview window a bit. I've added some UI. So we have a zoom, which just affects the length. The implementation is a little bit hacky. And since it's based off of the magnitude, there's some floating point errors that kind of pop up. But it's fine. And then there's a button that says export to STL. That doesn't do anything. That's what we need to implement. The rendering is also different. These models are not a single mesh. They're actually multiple meshes that are all later combined together. So what we need to do is actually, we already are collecting all of the meshes. We need to take those and export those to an STL. So the easiest way is to just extend our STL builder here. And this actually takes a mesh, but it's a different kind of mesh. It is coming from a mesh that we have built. This mesh, not Unity's mesh. And that's a very important bit. So what I want to do is be able to actually build this mesh, our STL mesh, from a Unity mesh. Don't know how that's going to work, but that's what we're going to try to do. So I'm going to create a static, let's make it just a static constructor. Public static void, not void, let's make a mesh, and we'll just say build. So mesh.build, and you give it a mesh, a Unity mesh, so Unity engine.mesh, and this will be the base mesh. And so effectively what I want to do is grab the name and also create a list of facets. So we need to pass in an enumerable set of facets as well as all of the information we might need. Right now it's just the name. So, is this going to work? No, not necessarily. We're going to... The issue is, unless I'm very much mistaken, STLs only support a single mesh. So, we're going to need to be able to support multiple of those. Let's do... Not like that. There we go. Params. And so this is going to allow us to give multiple parameters. So we can just kind of add the meshes on like so, or just pass in a list. Either one will work. And then it's just going to go and actually build this thing for us. So let's create a linked list of facets. And so facets are just triangles. They're just the faces. And we are going to actually pull out the normals and the vertices from that, and that should be all we need. So this is going to be our facets, new linked list. At the very end here, we're going to return a new mesh, and this is going to have some name. We're gonna expose that, so string name. Now let's just do that. Get rid of the whole Java string thing and do name, and then we'll grab our facets. So we're generating a mesh, but we're just generating an empty mesh for now. Now the hard part. We need to add each of the facets from all of the meshes in our list. And so I'm thinking this is going to work and hopefully they all just get stitched together. That may not actually work. We're going to have to kind of do some tweaking to see if that actually happens. Worst case, we kind of have everything separately. And then in some other graphic program, like 3D Builder, for example, we can just do a join to combine all of them. And then we don't have to worry about all of the math required to actually combine meshes, because that gets a little bit complicated and I don't want to deal with it. So let's, for each mesh in our base meshes, so we're going to just we're going to iterate over every base mesh that we get. And then we're going to take that, and for each of them, we're just going to add every triangle. So triangles are going to be coming from here. Does this work? Yes, this should work. So triangles are just indices that point towards other bits. So if I look at this mesh.triangles, it's just an int array. And each of those are going to be every triangle is just 3 indices that points to all the other values, which is going to be vertex color, vertices, normals, all of that is coming from this. So for int I equals 0, I is less than the mesh's triangle's length. Yeah. And then we'll just add 3 onto our index each iteration. So we're going to skip over by triangles, and that should hopefully collect all of them. No idea if this is going to work, but it's what we're going to try. So now let's grab our facets, and I want to add let's add it to the end. This really doesn't matter so much because each facet is actually independent. It gets kind of stitched together at the end. So the fact that they share triangles or they share vertices doesn't matter in this case. So we don't need to worry about that unless I'm mistaken. But hopefully we don't need to worry about that. So mesh normals. Every normal or every vertex has its own normal, not every face. Is that correct? That might not be correct. I hope that's correct. I should check this. What's the easiest way to check? Let's comment that out. Jump over here. This is sort of our playground for making everything a little bit better. Do our attach to Unity so we can actually debug this, and I want to just verify everything is correct. I could obviously look at the documentation, but this will be hopefully faster. I didn't need to start that. Why did I start that? That's not relevant. But anyway, we select this. What? Huh? Oh, it didn't debug. There we go. Awesome. So let's look at our mesh, and we have 4,272 triangles, which means just over 1,000, like 1,300 some actual triangles, and we have 1,460 normals, and the same number, if I can find it, of vertices. Awesome. So all of those maps are going to be the exact same. Just double checking that there. So let's go here. Grab our normals of our mesh triangles I. Yes. And so what I'm doing here is I'm looking up the index, which is coming from our triangles, and then we're plugging that into our normals and actually pulling out the correct normal. And we need to do that 3 more times. So mesh normals, mesh triangles, I plus 1. This is wrong. Hold on. Vertices. There we go. So I'm going to grab the positions first. The normals can come next. because I want to actually average those normals. We're going to get 3. We're going to sum all 3 of them and then divide that by 3. And that should hopefully get us sort of the average coming off of that, instead of it just being one of them, just taking 1, which would also work, but I wouldn't like it. So there's the final one there. And then we can close this. It is not going to like this because this facet is not expecting Unity stuff. It's expecting my own vertex class. So we need to go here and actually make it have a constructor that supports vector 3s. I could actually just change all of this to support or to just be vector 3s, but this way we kind of keep them separate and we don't have to rewrite all of that code. So this will be our vector. So we're going to do this.x equals our vectors x, this.y, vector y, and this.z equals our vectors z. Awesome. So that's done. Now let's grab this again. Okay. Tried everything but the one I needed. So we're going to create a new vertex from this. Another one from this guy. And the final one from our third vertex. And so this is the definition for our triangle. That's all we need. So we're taking the current index, the 0, first and second index, and then we're skipping 3. So it'll be 3, 4, 5 will be the next triangle, and then 6, 7, 8 is the next triangle, and so on. The only thing we need now is the actual normal, which that's going to be a little bit harder. We are going to want to calculate that. And so this gets a little bit hard. Our vertex class does not support any sort of addition or anything. We didn't code that in. It's strictly a data type. So we're going to stick with vertices or vectors for now. And then we can convert it when we actually assign it. So if I pull all of that off, we get a sum. And then let's just stick a division by 3 in there. So divide by 3.0, and that should get us the average of 3 vertices, hopefully. And then, now that we have that, we just need to plug it in. So new vertex of our normal. Let's stick a comma in there and not a semicolon. That would work a little bit better. And so now that we have all of that, this should, yeah, this should totally work. So assuming everything is correct, we're going to iterate over every mesh that we have passed to this function. And then we're going to take every triangle in every mesh and add them as facets to our to our mesh. And then we return a mesh, which we can then use to build things. So this STL builder takes a mesh and outputs an STL file as a string. And then we can just export that to a file. Simple-ish, hopefully. So that's the general idea. Will this work? Yeah, sure. This ought to work. Let's do a mesh builder dot create and with facets. Build. Build is what I want. Is it? Wait, hold on. I was doing the mesh. I got it. We have a mesh builder. I should have used that. Why did I build a second builder? But anyway, that's totally fine. Let's do an STL builder.mesh.build, and I want to build it from a list of our meshes. So we're going to just build a temp model. Let's call it the Unity export. It's not fancy, but it'll work. We could obviously add a input field for text or for the name of it. I don't really care, so I'm not going to bother. But then what I'm going to do is take, for all of the mesh filters, I have a combination or a set of mesh filters here. What I want to do is actually iterate over all of those and grab them and convert that to an array. So let's select from the filter, the filter.shared mesh. Either one should work. I'm going to use the shared mesh. And then let's array that because our function is expecting an array. And so this should pull out all of the meshes and send them down to our build. And then this should give us a mesh, our mesh export. Cool. And now that I have that STL file, we're just going to run this through the STL builder and build it from our mesh export, like so. Now we have a string that is our STL file. And so with that, I just need to save it somewhere. So let's just file util. Okay, I guess Unity is trying to use its own thing. I don't think this is what I want. There's just file. There we go. File dot write all text to let's just write it to somewhere I'll know. Let's see. D:// our mesh. D stands for data. That's why that's my drive for data. And so we're just going to write our STL file to our mesh.stl. And hopefully now we should be able to export this fun little minaret. Not really a minaret, it's just sort of a tower, I guess. Let's finish building. Cool. Let's click export. It's going to take a bit. It should be done. One sec. I'm going to go try to load this into 3D Builder and hopefully we can send it to a printer and see what we get. Huh. Okay. So it kind of worked. This is the output that we got. Which, first off, it's kind of sideways. But also, that doesn't look like what we had in Unity. Why don't you snap? There we go. Okay. That's cool, though. It looks like it almost got squished at the top. I don't know what happened there, but it just looks squished. Like something didn't work up top. Everything else seems fine, though. And I'm actually kind of surprised that it actually kind of worked. So, yeah. Just for reference, this is sort of what we were expecting. So I don't know entirely what happened up here. It's kind of hard to judge because I believe everything is there. It just looks like it's maybe not right. And what could it? So, oh, that could be it. I wonder. Okay, help. I am lost in the model. So, what I'm thinking happened, these aren't necessarily zeroed. And so what I'm thinking could have happened is when we exported this, like say this little ball on top, that one, it's at the top there, but that's because it's transformed up. The only thing at 0 is going to be this root. Everything else has been transformed in some way. And we aren't capturing that. So I think that's what's causing this error. And is there a good way to do that? Maybe. So we have our mesh. Can I export a new tuple? Let's create a container type. This is going to be a little bit messy, but again, this is more an example of how you might do this. This isn't necessarily the best way. So we're going to create a mesh container. And so this class is just going to be two properties. The first is going to be a Unity mesh. And so we're just going to call it mesh, like so. Cool. The next one, Unity engine dot, let's just do a vector3. And this is going to be our translation. And so this is going to be the translation in 3D space. Only position, not talking about scale right now. Hopefully that doesn't become an issue. But we could add on to this obviously as we need. So then, let's make this a mesh container that it expects. All of that breaks, but that's all right. Because now, I need a mesh out of this. So let's grab container here and make this our mesh. So mesh equals the container dot mesh. Cool. Everything works again. The normals are still fine. That wouldn't have broken. But then instead of just doing the vertice, we're actually going to add on a translation, which is going to be the container's translation vector. And so this will actually position it so it's correct, hopefully. That's not right. Cool. And so now everything should be translated to actually fit. The only thing we have now is this being broken. So go away. Let's do a mesh container. And we're going to assign the mesh, like so, equal to our shared mesh. And then our translation is going to be a little bit more difficult. We want to take the filter, transform position, and subtract it from the selected or selection game active game object dot transform dot position, which is going to be the root node. It's going to be what is selected by default. So effectively we're getting a position relative to whatever the root selected object is. Not necessarily in world space, because that way we don't necessarily need this to be positioned at 0, 0 in the world. We can just kind of work with it wherever. But hopefully that fixes things. So if I export this again, that's not going to work because it hasn't compiled yet. But let's see here. That does its thing. We export. Hopefully no errors. Awesome, it's working again. Let's open this. And I'm going to just reload the file quick. And we'll see if it worked. Huzzah! So this is our mesh. And everything looks correct now. So we are now exporting meshes as STL files from Unity into any other 3D modeling program, really. And so now we can print this. There's nothing that's going to stop us from 3D printing this. So I can send this to my 3D printer. I won't probably show you that today or maybe even this week, because I'll probably tweak it a little bit to make sure that it actually turns out. And with something like this, it's not going to be the easiest print, but I'll see what I can do. That's totally unrelated. My 3D printer is cheap, and so depending on the quality of your printer, this may or may not work. But you can take anything. You could take a mesh of a character doing something and export that. And you could actually theoretically select like a full scene, Like you could select a cube of data or whatever, of whatever's going on in your scene, and actually export that and then print it. And so theoretically you could actually take like set up a scene in Unity and then send it to a printer and do whatever you want. So yeah, I think that's cool. Well, I don't know how well it's going to actually work, but I will update you guys once we actually get this printing. Hopefully, probably sometime next week, actually, just with schedules and stuff. But anyway, that's what I wanted to get done. Hopefully you guys found that interesting. I think this is cool. It's, I don't know. We can take a model built out of just nodes, and I can tweak this too. So this is Archimatix. I did a video on this yesterday, but if you want to like tweak this and maybe do whatever that is, you can do that, and everything just kind of works. And so we can export this now, and it will just show up and be ready to print. So I don't know, I think that's cool. We can do a whole bunch of stuff with this, whatever we want. Even something awful like whatever that just was. So yeah, that's a thing. But I hope you guys enjoyed this. If not, let me know in the comments and I'll try to do better. But if you liked it and you want to see more, hit the subscribe button or let me know in the comments so that I know that people are learning something. But that's it for this video. So until next time, see you, Internet.